For the second video, we'll discuss cloud-based collaboration. Our connected platform is called BIM 360. BIM 360, that's not only where the project data sits, it can be, of course, be analyzed, and reports and dashboards can be used to analyze this data. It can also be customized via Autodesk Forge, and we are, of course, using this BIM 360 platform to connect all the desktop-based software we discussed in the first video, such as Revit, AutoCAD Plan 3D, InfraWorks, Navisworks. And we are also proposing via Autodesk Forge, which are the APIs of the BIM 360 platform, which, by the way, we also use to develop our BIM 360 solutions. Using these APIs, Autodesk Forge, we can either build a custom third-party application link, such as point clouds or cost systems, planning systems. And we also have a quite large ecosystem of other software providers that connected their solutions to our platform BIM 360 using Forge. So the data sits on BIM 360 docs, which is the recipient of project data. And we also have products for specific needs, such as design, like BIM 360 design, which others is co-authoring design in Revit, Plant 3D, Civil 3D, pre-construction solutions, such as BIM 360 Coordinate, and BIM 360 Build for field execution, which takes care of quality, safety, progress tracking, and of course, work coordination. Let's talk about design. Design collaboration can be performed with BIM 360 Design, which used to be available for Revit. Could organize work sharing on Revit files. You can see the macro disciplines we discussed in the first video here: structure, architecture, and MEP. And during the past weeks, it was also integrated to AutoCAD Plan 3D. So we can use AutoCAD Plan 3D and BIM 360 Design to co-author our project. Basically, the plant project sits in the cloud in BIM 360, and everybody can reach it from within his local project on his laptop or personal computer. In case users do not wish to use cloud solutions for part or their entire project, we can always work behind the company's firewall using Vault Professional, for example, and which is our solution for data management on premise. So if we had to focus on the collaboration for Plant 3D using BIM 360 Design, we are addressing here the challenges that we mentioned in the introduction in the first video, which are, of course, security, access, accountability, providing solutions to help teams communicate better with each other, and solutions that are easy to access, easy to use, easy to learn, because we all perfectly know that project complexity is growing and growing every day. Collaboration for Plant works with Plant 3D 2021, which is the latest release that was released about 2 or 3 weeks ago. The idea is, again, to work on your system, on your computer, and we can collaborate between AutoCAD Plan 3D and BIM 360 Design and the cloud. We use these solutions to share design models with other AutoCAD Plan 3D users And those users can either share P&IDs or 3D drawings, of course. Also, one of the aspects, one of the features of these solutions can connect AutoCAD Plan 3D P&IDs generated with Plan 3D with Revit in case our users wish to model 3D piping in Revit. So, just as a summary, why um, could we use collaboration for AutoCAD Plan 3D, BIM 360 design for AutoCAD Plan 3D? Um, the idea here is to connect different offices, most of the time geographically dispersed, and to allow them to have a secure and performant connection one to each other. There's no file or database server requirements involved in this process. We are working on a with file locking and versioning through a concept that has been developed with Autodesk Vault, which is check-in and check-out. When I need to work on a document, drawing, model, I will check it out, which will reserve it for me, open it in my system, and lock it for all the other users. All the other users can access it read-only, which is great and secure. Once I'm done doing changes or performing design on a model, I can check the file back in, which liberates it for all the other users and basically creates a new version in the system in the cloud. One of the reasons why we brought BIM 360 design for Plant 3D to the market is that we needed a performance increase because we work locally on a collaboration cache project. By the way, we don't download all the files, we just download from the cloud the files we need to work on. Basically the files and some of the external references, the XREFs. Also, people who are used to work with AutoCAD Plan 3D, um, um, their way of working will require minimal change because the system is integrated directly in there in the software. Um, the administration part is also using a check-in check-out system, which also secures the fact that a BIM admin, a CAD admin can easily go check in and check out the setup files to modify them as the project leaves. And BIM 360 design for Plan 3D, it also proposes a highly configurable um, permission control, which sits on which is the permission control of BIM 360 docs, which has been proven a great solution for a few years now. So how does collaboration work? Let's dig in a little bit further. This is a workflow, a chart showing the classic SQL project configuration, which requires file servers, databases, and by the way, working with LAN and also on the wide area network, which may cause a few problems. Might require VPN access, which does not solve any bandwidth challenge. The fact that we have file servers, most of the time virtualized, but file servers anyway, and SQL Server instances for databases will of course require maintenance, implementation, and um, server work from your IT, of course. Now, if we had to discuss the cloud collaboration compared to that SQL database slash server kind of collaboration, we will use the internet, the internet connection, perfectly secure internet connections to synchronize the local projects of user A and user B, which who is remote, of course, to check in, check out, or refresh the data from the project. By data, I mean, of course, the drawings, but also other documents such as spreadsheets or PDF drawings or documents. So the idea is to propose a system based on cloud and local cache. Collaboration for Plant synchronizes the collaboration cache with the BIM 360 project. You can see here a view of the interface, the user interface in a web browser. You can see the BIM 360 Docs project with the folders and subfolders and files. And on the right side, the collaboration cache on the user computer, which is structured exactly in the same way. So which versions of Plant 3D can I use to collaborate on the cloud? In the past, we used to have collaboration for version of AutoCAD Plant 3D 2018 to 2020. We used to collaborate on the BIM 360 Team Cloud, which we of course maintain, but we do not develop it anymore. So to work with BIM 360 design and the workflows we just described, you will need AutoCAD Plant 3D 2021, which is the latest version. There's no migration required between 2020, 2018, sorry, and 21 in terms of AutoCAD Plant 3D projects. We did not change the format. So if we had to insist on a specific collaboration aspect of Plant 3D Cloud collaboration, um, it would be to involve more and more stakeholders in the BIM process. I can have my plant designers, my P&ID drafters, third-party contractors, very specialized and in need of a specific design tool, just like AutoCAD Plant 3D. But I can also involve all the other stakeholders like cost estimators, plant managers, or consultants by using BIM 360 design in conjunction with AutoCAD Plant 3D. How do we configure the project? So this is a bit technical, but this is just an example of a highly controlled permission settings. Um, the system is quite flexible, so we could make it very open or just like in this case, highly controlled. The plant project folder can be assigned permissions per person, companies, or roles, as you can see here. So this is a BIM 360 classic feature. Roles can be also customized, so we could also call them groups if needed. We can perform exactly the same on the P&ID drawing folders and on the 3D model folder. So we can imagine having very granular permission access settings for every kind of stakeholder that has to access the project through Plant 3D, but not only through Plant 3D, but also using the web browsers or the mobile apps, of course. We can consider permissions for deliverables, eventually the recycle bin, etc. When using BIM 360 Design for Plants on a cloud project, you can actually see the file status in the project manager, as shown on this image. And you can browse the different file status. Anytime you work on a cloud project on a cloud file on BIM 360, you will, in a live manner, know the status of the file you are working on or all the other files. If they are checked out to somebody else, which will give you only read-only access, or if they are available for you to open them to check them out and modify them. Everything has been done to make the workflow easy to access and easy to use. We can set up default behaviors. For example, I don't need to manually check in or check out drawings. This can be set up to be automatically done when opening or saving files or closing files. We can also set up the how many times we check for updates and if it's every 15 minutes or every hour, for example. So this can be again done manually or automatically, as shown here. Let's now take a look at a short video showing BIM 360 design and plant 3D. This is what we called cloud plan collaboration. So the first workflow to start would be to set up a BIM 360 collaboration project here. To add permissions to the folders. To upload the cloud project from within Plant 3D. We can actually check in drawings, new drawings or modified drawings. We can, of course, work as usual in Plant 3D, checking in our changes and making them available to other stakeholders. This also works for deliverables such as isometrics or auto drawings. Can also add bill of materials, which will be accessible either in Plant 3D for other designers at the other end of the world or in a web browser, just as you can see it here. We can not only consult the different documents in a web browser, but also comment them and access their properties, just like the ones in AutoCAD Plant 3D or on our P&ID drawings. Now let's look at another example of using the clouds to modify or to interact with data. What I will show you here is export and import spreadsheet data from Plant 3D to Excel, but also using the cloud. So meaning the Excel file is in the cloud as well. Let's take a quick look. I'm actually in Plant 3D. For those of you who already know plants, they know that I can use the data manager to export specific data. For example, here, inline valve elements, a table of inline valve elements, I can actually export it to Microsoft Excel spreadsheets. The difference here is I will do it to the cloud. Instead of exporting locally, I'll export the spreadsheet to BIM 360. This is using Desktop Connector, which is a software we can install on our local computers to interact with the cloud. We can then use Excel Online to eventually modify the data in the spreadsheet. Data like manufacturers, model number. We can also assign close the valve, for example, and we will see that we can re-import the modified changes back from the cloud as well. So this can be another person using Excel Online. Again, we can have thanks to desktop connector, we will have some of the information available on the clouds. You quickly saw that my Excel spreadsheet was in version 2. And then once imported, the changes are highlighted and we can, as usual, accept them or reject them. A log file showing that the changes we accepted or rejected is available both in the local cache and in the cloud. So everything is kept track of. As you can see, the log is also in the BIM 360 docs. We can also look at another aspect of BIM 360 collaboration for Plant 3D, which would be the mobility. Mobility is very important because not only can you access all this data that I've published from Plant 3D, for example, from mobile phone or a smartphone or a tablet on Android or iOS, but you also can interact with them. And one of the most important aspects is that we can work offline, meaning that we can go on site where no Wi-Fi or any internet connection, any phone connection is available, and we can still work. We just have to prepare a bit our work and download the files locally in a very easy and straightforward way. So here we involved mobility, of course, and we are going to generate issues on a tablet and analyze the changes that were done in the design programs using BIM 360. So this involves mobile apps, BIM 360 mobile apps on iOS and Android, Plant 3D and web browsers. Let's take a look. So this is my Android tablet. I'm accessing exactly the same project that my colleagues are working on. They can be working on actually. I can look at the P&IDs. Some of them, I can actually download some of them in the local cache, so I can work offline. I can also review drawings, create markups, and also create an issue. Should I need to do it? I will do one specific on that specific point on the drawings where you can see a valve. I'm wondering if the tag was updated accordingly to the latest meeting, for example. So an issue can be assigned to an individual or like a group or a company. We can then provide a due date. People who are assigned this issue will receive emails with a direct link to the issue and the model, the drawing here. We can do exactly the same review for 3D models. This is how we would work. We can use sectioning tools. I will, in a few seconds, also show measuring tools. And the beam aspects of these solutions are that we not only see the geometry, but we can also have a quite deep insight into the object properties. You will see object properties that which were created with Plant 3D. Center of gravity, weight, bottom of pipe, top of pipe coordinates, the spec, of course. All this very important info we need to have to deal with our more and more complex projects. Just like for the P&ID, the process part, I'm creating an issue here. I'm asking my colleagues to check the spec. And we'll also provide a measure to illustrate all that. So basically, I'm just making a measure, and take a screenshot and add it to my issue. This could be also a photo, by the way. We also can pick up a root cause, which is called a root cause. So what generated the problem in first place? So we can analyze the issue root causes and have the system provide us with reports and dashboards. We can then visualize the issues we created on the P&IDs and 3D models in a web browser interface. A direct link is provided. In 2D, of course, it's linked to a specific point of a drawing. You can then go back to Plant 3D, check the remark that was sent from the field, change the tag, save the drawing to the cloud. Remember the check-in operation I was telling you. Can eventually include a few comments. So we can keep a record of changes. Can do the same for the 3D part using again the web browser. Now we published another version of a P&ID drawing. We can compare the two versions and the system will highlight the differences, specifically the change in our valve tag, which is quite valuable to understand what changed and what didn't. In 2D it's more graphical. You will see that in 3D the same tool will show differences, much more insight, I would say. You can now go ahead, click on the issue and close it as it was resolved. As usual, we can add a comment for the record. As I told you, we can do the same thing for 3D models, piping or structure, equipment drawings. We can have keep track of the activity for this issue. We can analyze 3D drawings here, look at issues assigned to objects. Please notice that when I clicked on the issue, the right object appeared with the right zoom size, etc. We can actually check the spec as requested. We can now, for this collaborative project, go to the right drawing, open it. We can now update the spec and change a bit the routing of this pipe system. I will go ahead and change the nominal diameter, for example, and modify a bit the routing. I will also add a new gate valve. Maybe change the type to add reducers. Once I'm done, I can go ahead and check back in the drawing. Again, I can include a few comments. The new version I just published to BIM 360 because again, when I check in a file, it's written in the cloud. Once I have a new version, I can use the version comparison tool to have the system analyze the differences between the two versions and show me a summary of what changed, what was deleted, or we will now discuss another aspect of BIM 360, which is the approval workflow. This is done in the document management module and is quite valuable here. Let's take a look at this short video. So we can set up an approval workflow, which is composed of 1 to up to 6 steps. We can assign the different roles for every step based as usual on individuals, groups, or companies. The different approval statuses. And we can also pick up a folder where we can actually copy the files once they were approved. This allows us not to interfere with the work in progress project. So once approved, the files are copied in an external folder where they can be accessed, for example, by external consultants. Now, how does it work? First, we will select a file to review or a folder that works as well. We will select a file, which is actually a 3D file, submit for review. We just pick up an approval workflow, the one we just set up. We can also add documents. For example, we could, I don't know, add a few specific P&ID documents. So it's not only for 3D, it can be also for 2D drawings, but also other documents such as PDF files. Once I picked up the right documents, I just click for I just submit. I can actually add members to notify them, which are not necessarily part of the revision cycle. A dedicated page shows the different reviews that are ongoing on that specific project. So the person who reviews the documents, he or she can check, use markups, and provide eventual comments if changes need to be made or information need to be passed. We can easily check properties in 3D piping or P&ID objects as usual. P&IDs are intelligent as well. As you can see, this valve is an intelligent element. It's not just line drawings. Now let's start the review process. Take a look at the files, eventually add some comments, and just pass it to the next step. So this marks the end of the initial review. This would be our second step, which is the final review. I will start it here. Take a look at the files, see if they have comments, consult them, analyze them, and then eventually approve them. Once approved, they are copied to another folder as set up initially. So they were copied to the folder called approved files. We can always have a look at the progress, track the progress of the review workflows, and then they are copied in the approved documents folder, where they can be shared, for example, with external consultants or internal folks who don't use Plant 3D, for example. A summary of the of the review workflows can also be exported to Excel, either to save them, either to use them or to connect them to another system. So everything is tracked, which makes the work way more consistent. This was the approval workflow. Now let's say two words about server locations. So for our cloud servers, we can provide for all the solutions, being BIM 360 Docs, Design, Coordinate, or Build, servers based in the USA or European servers. For managing content when working with the cloud collaboration tools, usually, as you have seen it in the first video, the BIM 360 projects will use a check-in, check-out by the admin, check-in, check-out by the admin feature. Um, it's still local. It will be changed locally and then saved to the cloud. For the catalogs, usually they are on a network drive or on local computers. They can be synced with any syncing tool available on the market. Just another word about P&ID to Revit. We mentioned that a bit earlier. Some of our users would like to perform P&ID design into Plan 3D and do 3D piping with Revit. So this is possible now. Can use P&IDs from the BIM 360 Design Cloud Collaborative projects in Revit to model 3D piping, as you can see it here. This is quite new, so today it's only available for US servers. The system will require a mapping of the P&ID service and the Revit system types, and also a mapping of the objects and properties, meaning the 3D objects and their properties. So the current workflow is we generate a P&ID in Plan 3D, then we open the P&ID drawing in Revit 2021 only with the latest version of Revit. 3D elements can then be modeled. Elements means equipment, pumps, valves, pipelines from the P&ID, and the status can be tracked, meaning that the system will tell you which line was placed or not yet in Revit. And the Revit project can be local or a cloud collaborative project using BIM 360 Design itself, the Revit collaboration for BIM 360 Design.